Okay, welcome to video 2 on Radians Intro, and we're going to talk a little bit about arc length, but we're going to do angles on the unit circle, positive negative angles, radian measures, because we've just focused on degrees right now. We're going to convert between degrees and radians, and we're going to do arc length. Okay, so let's talk about what the definition of a radian. First of all, you guys are used to 360 degrees in a circle, and who said that you have to take a circle and divide it into 360 pieces? So the radian was defined as they took a radius of 1, an arc length of 1, and another radius of 1, and they cut this little piece of a pie, if you will, out, and that was considered a radian. Now, if you were to look at this, if you were to kind of cut this a little bit, and this is not exact, mind you, you'll see I have a little over 6 pieces because this piece is kind of big here. So there's a little bit 6+ pieces of this circle that's been cut into a little bit 6 pieces. So the reason why I'm telling you that is because when I first learned radians, I tried to memorize how many degrees it was. I really don't want you to do that. I just want you to get an idea that you have a little over 6 pieces in this circle. Okay, now here is this arc length here, if we're talking arc length, and you'll see the arc length is whatever is spanned by the end of the angle of that radian. So that little piece there is called arc length, just so you know. Okay, now let's look at the relationship between radians and degrees. Now, I'm going to start this off by saying a circle is the same as the circumference is going around the circle is the same as pi times the diameter. Well, if a unit circle has a radius of 1, my diameter is actually 2 radians. Excuse me, 2 radius. So if I were to actually do the whole diameter, my diameter is 2. Okay? So I can either call it 2 pi of my 2 radiuses, or I can say it's just 2 pi because if my radius is 1, it's going to come out to be 2 pi. Now, that's important for you to know because now I can say, oh, it's 360 degrees around my circle, as well as we can say it's 2 pi around my circle. This is in the degrees, and this right here is in radians. All right? Now you're going to be able to tell the difference between the two because you will see the degree symbol there if I'm talking degrees, and you will see nothing if I talk radians. So if I take and divide that by 2, or take 2 pi divided by 2, I can also say, oh, okay, so 2 pi is equal to 360. That means pi is equal to 180 degrees. Now, this confuses people, so I want you to think like this. So I'm going to find a little spot over here. I want you to think units, okay? So let's think this way. If I were converting, I could say I have 12 inches is the same as 1 foot. That is a smart one. That's what I call that. But it's 2 different units. So this is A1 because 12 inches and 1 foot are the same thing. It's just different units. Well, in this case, I could say, oh, 2 pi is the same as 360 degrees, or I could say it this way, 360 degrees is the same as 2 pi. But we don't do that because you can reduce this down, and so we use this. Pi over 180 or 180 degrees over pi mean the same thing. It's A1. It stands for 1, and we use that to convert between the two. And I made a little chart here so you could look at it. One thing I do want to show you is when I go around this circle here, I say this is 0 degrees, or I say 2 pi, which is a little bit over 6 pieces at 6.28. This is pi over 2 because I know pi is 180 degrees. So 180 degrees is the units for that. Pi is a little bit as 3.14. If I take and divide it in half, this is 1.57 radians, or I can say 90 degrees. Take and go halfway here, it's 270, or 3 pi over 2, which is a little over 4.71 radians. So if you were to look at this, if I'm converting between degrees and radians, pi is the same as 180 degrees, and 2 pi is the same as 360. if I'm talking radians, pi is 3.14. Now that's rounded, and 2 pi is 6.28 radians, which is a little over 6 pieces of the pie. Now let's look at radian in degrees here, and we're going to practice doing this, but I can go 0, 90, 180, 270, or I can do in radians. So I'm going to have you practice the difference between. So if I wanted you to graph 2 pi over 3 radians, I know you can convert it to degrees, but I want to show you a trick. What I want you to do is to draw this, and then I want you to call this 0, and I know it's 2 pi, and this I know is pi. But if you look at the denominator, say, okay, there's a 3 there, I can write pi with a denominator of 3, or saying 3 pi over 3. And if I come over and I know this is 2 pi, or this doubled, I just double the top, this is the same as saying 6 pi over 3. Well, where would 2 pi over 3 be? Well, if I count 1 pi over 3, 2 pi over 3, 3 pi over 3, 2 pi over 3 would be right here in this quadrant. Okay? So we're basically trying to see which quadrant we're in. Okay? We can practice another one. What if I gave you, so that I don't have to keep converting back and forth, where is 11 pi over 6 radians? Okay? Now remember what I told you. Start 0. I know this is pi. Use the denominator that you're given. How would I write pi that way? Would be 6 pi over 6. When I come over here, I know it's doubled. That's 12 pi over 6. Where is 11 pi over 6? Well, you count. Here's 6. Go all the way over here. 11 is right before 12, so I'm in the 4th quadrant. Okay, let's try another one. What if I gave you 5 pi over 4? Where is that in my quadrant? So I'm going to draw this. Remember 0. I know this is pi, but we're going to use the denominator of 4, so I have to write it as 4 pi over 4. Come all the way over here, double it, 8 pi over 4. It's pi, guys, sorry, over 4. Where's 5 pi over 4? Well, it comes a little bit here in the 3rd quadrant. Okay? What if I wanted you to do where 9 pi over 4 is? So let's look at 9 pi over 4. 9 pi over 4 is the same thing, but now, this is over 4, by the way. It's not writing very well. I'm going to come all over here, and I'm going to end up back in the 1st quadrant. All right? But what if I asked you to find where 5 radians is? Where the heck is 5 radians, or just 5? Well, this is when you, instead of using pi, I say to myself, all right, this is 0. I know this is 3.14 roughly, and this is 6.28 radians. Where's 5? Well, 5 is about here in the 4th quadrant. Where if I asked you where 2 radians was? Well, 2 radians, this is 3.14. 2 radians has got to be, let me see, where would 2 radians be? Oh, it'd be over here a little bit further. So, because it's close to 3.14, if I put this in half, it'd be 1.57, so I know it goes past that. So you can quickly find what quadrant you need to know as long as you label it the way you need it. Okay? Now, converting between the two of them, you're going to convert 150 degrees to radians. So, use your smart one. I don't want you to memorize it, but when you multiply it, you're either going to use pi over 180 or 180 over pi. You want to get rid of the degrees, so put the degrees on the bottom and multiply with the pi on top. All you do is simplify that. You have 150 pi over 180, which reduces to 5 pi over 6. Okay? If I want to do 135 degrees, I do 135 degrees times pi over 180. And that would reduce down to 3 pi over 4. Now, if I want to convert 5 radians to degrees, this is in radians, so I want to put radians on the bottom and the degrees on the top. And when you multiply that out, you're going to get a decimal because pi is a decimal. You're going to get 286.48, or roughly 286 degrees. 2 radians would be 180 over pi again. So when I multiply that, I get 114.59, or roughly 115 degrees. Okay? And the last little piece I want to show you about this is arc length. So we learned this is S equals R theta, or S equals SOR, theta times R. So it's radius times radians is arc length. So if I have, and you have to have radians in your equation, you can't have degrees. So if I had an angle that was 120 degrees, so that's going to look kind of like this. Well, actually it's a little bit bigger, but roughly that. Has a radius of 12, and this is 120 degrees. Okay? What's the arc? And the arc is called S. So I do it like this. I say, okay, S equals R times theta. S equals 12 is my radius, but I can't write theta here. I have to convert it. So I go, okay, what's 120 degrees in radians? So I have to multiply by pi over 180. So that converts to 2 pi over 3. So I put 2 pi over 3 in my equation. That reduces down to 8 pi or 25.13. Okay? This one tells me what's the angle in degrees that has an arc of 25. So I'm just going to do this simple angle here. Arc is 25 and the radius is 11. So I say, okay, S equals theta times R. The arc is 25. The radius is 11. If I divide it out, theta comes out to be 25 over 11. And if I want that in degrees, I have to convert that by saying, okay, that's in radians, so the 180 goes on top, 180 divided by pi, so it's roughly 130.21 degrees, or 130 degrees. Okay, so that's a little bit of basics of radians and degrees.